Hey, how's it going, everyone? Good to have some. Whoops, that's the phone. I'll turn that one on to mute. Good to have some people. I honestly thought that after having like a week and a half off, due to several reasons, that there'd be no one around. So that's cool to have people around. What have I been up to lately? I think the last thing we did was looked at. By the way, again, usual disclaimer: audio levels, music. Let me know if anything's too quiet, too loud. I think we're between tracks right now. Yeah, so it's kind of quiet anyway. But let me know if the music's too loud or too quiet. I think the last time we chatted, I was looking at implementing some stuff into Pwn Tools. I should have. Oops. Let me get my Docker container. Actually, you know what? We might be talking Docker tonight, so I'm not going to do that. Let's just do this. No, I don't want to do that. Give me 1 second. Let me just get a Docker container up and running for Chromium. Okay. Whoops, wrong one. Last time we spoke, I was looking at introducing some new functionality to Pwn Tools, which is a tool that is, or a library that's very near and dear to my heart. We were looking at putting the Metasploit cyclic pattern generator into Pwn Tools. And where we left off was me being very upset about the performance of the generator that we'd written. GitHub Pwn Tools. And the good news is I figured out why its performance was so abysmal. It is because, in fact, this Docker machine should have the old Pwn Tools. Let's do Python import Pwn, print pwn.cyclic 100,000. So we were doing stuff like this, and we were printing a whole bunch of stuff using the inbuilt pwn.cyclic, like a length of 10,000, 100,000. And we were looking at the speed of that compared to the speed of what I was implementing, which was doing 100,000 characters, and it was taking so much longer than the Pwn Tools one. The reason why is because, yeah, there we go. So 100,000 is not enough. Let's do 1,000,000. If we ask Pwn Tools to punch out 1,000,000 characters, we only get 500,000 characters out of it. So we'll tack a couple of zeros on the end here. We still only get 500,000. So Pwn Tools was lying to us. It was, well, what it was doing was, it was doing exactly what it is documented to do. Help pwn.cyclic. The cyclic function inside Pwn Tools says that it is a simple wrapper over the function daemon. This function returns at most length elements. It does not promise to return exactly length elements. And if you look at daemon, I think we should be able to do help pwn.daemon. Yeah. Generator for a sequence of unique substrings of length n. This is implemented using a daemon sequence. The return generator will yield up to the length of alphabet to the power of n elements. So, I mean, this is doing exactly what it was advertised as doing. It was generating as many characters as daemon would punch out without looping on itself, and then finishing up. So even though we asked for a big number of characters, we only got a small number of characters. So I complained about this, and it got fixed, because that had me scratching my head, as you saw on stream, for way too long, and feeling quite embarrassed about my cyclic pattern generator. So you can see here I reproduced it on the issue tracker, and it ended up being that it now hard errors out if you ask for too many characters. So at least you don't continue using the library thinking you got as many characters as you asked for. At least it basically yells at you and says, you've asked for too many characters, I can't do that. So the good news is once that was sorted out, and I benchmarked the generator based on 500,000-ish characters, 456,977 characters. My generator was actually on par with the PwnTools generator. So it wasn't that mine was horribly inefficient. It was that it was doing more work than I thought the cyclic generator was doing. So we should be able to opt PwnTools. Grab PwnTools. Get the development. Oop. This must be totally out of date. So here you go on the dev branch of PwnTools. You can see that they've landed my cyclic Metasploit. Import pwn.cyclic Metasploit. 64 characters. What's it whinging about? Pip install. Hope I've actually installed the PwnTools that I just checked out. Come on. How's it going, LM to Fatter Man? New to hacking, welcome to the world of hacking. It's good fun. It can be frustrating, as it was for me last stream, but it's rewarding if you really get into it for the right reasons and you try again. It's good fun. This is horrible. And maybe you can just trust me. Well, let's keep talking while this happens. So yeah, ended up getting that function implemented. So PwnTools on the dev branch now has a cyclic Metasploit generator. There we go. We almost done. Come on. There. And so then after that, there we go. We go up. There we go. Cool. There we have an implementation of the Metasploit generator. Opt Metasploit framework, tools, exploit. Oops. Exploit pattern create length 64. Come on, Ruby, wake up. There we go. So we've got a faithful reimplementation of pattern create, the Metasploit brand inside PwnTools, which I think is quite handy. It's going to be super useful for stuff like Windows exploitation. When you're debugging with WinDebug or Immunity with the Mona plugin, you can do bang Mona find MSP, and you can, in your exploit development environment, you can punch out a cyclic Metasploit pattern directly in your script rather than having to kind of copy paste this text here. You can just go and put this in your script, which doesn't look like that big of a deal, but when you've got a really long Metasploit pattern, you don't want to be copy pasting that in the middle of your script. It looks horrible and it wraps and goes awful. To be able to just put that in your script is much nicer. And then once you've got that in memory on the target system and you've crashed the process, you can use Mona's find MSP to go and hunt it down in memory. So I think that's kind of useful. And then what happened after that? I think that was the night directly before RuxCon, I think. RuxCon was good. I really enjoyed it. I learned a lot, went to some really cool talks, met some cool people, and drank a lot of good beers. So that's the signs. This is kind of warm in here. I'm turning the fan on. That's a sign of a good conference, I reckon. Well worth going to. Then after I got home from conference, Wednesday rolled around and I just did not feel like streaming. I was more than exhausted. So I needed a night off to recover, catch up from conference, and not stream. So here I am, like a week and a half since the last stream. But it was good. Conference was good. And I threw out in the channel, how does one fix scrolling in Tmux that doesn't scroll the old commands? How do you mean, Barney? While Barney gets back to me. As I said, take a peek down at the topics I might stream one day section, because I kind of didn't really have anything planned for tonight. I didn't really feel up to getting my ass kicked up and down the street by that last micro-corruption level tonight. Got some other stuff that's not quite ready to present yet, so I can't do those. I thought of doing a bit of a selfish stream. I've wanted to look into some alternatives to RVM. RVM is great. I use RVM every day. In fact, you probably saw it right here. I use it to manage my multiple rubies and multiple gem sets. But I know there's a lot of functionality in RVM that I don't use and I don't need. So I wanted to have a look around. I've heard of RBEnv, I think it's called, which sounds like a much lighter weight solution. And in my interest of running Tmux, running i3, minimalist everything, I thought basically stripping my Ruby manager of all the functionality I don't need and using something that only has the stuff I do need, like RBEnv, would be a good idea. So I thought if there's no other suggestions or if no one's super keen on something tonight, I might do a bit of a selfish stream. I might go and explore how RBEnv works, because you need to get some plugins like Ruby build to get it up and running really. And I wanted to kind of compare and contrast that to how RVM works to see if this would be a suitable replacement, drop-in replacement for RVM for my uses. So that's one thing we can do. I think I saw some people. I'll come back to in a sec, Barney. Docker for hackers. Seeing you explain do stack buffer overflow good would be cool. I'm thinking of doing that. I probably won't do that tonight. I've been thinking of doing that. I'll rehearse it a bit and I'll do like a really bang up job of it. I will record it in high quality, so not just the stream, but I'll have OBS set up to stream it, so there can be questions and answers and that kind of stuff. But as well as that, I'll spool it out to disk as a high quality video. And what I can do is, if I'm happy with the way it turns out, I can release that video Creative Commons. So just like all the material for do stack buffer overflow good is freely licensed, I'd really like a video presentation of me actually going through the slides, actually going through the demo, that I can release under Creative Commons to kind of finish off that series, close that loop, and have a full freely licensed set of training material. So I might do that another night. Burp. Yeah, I could do burp. I don't really know how much I would show of burp. Plus I don't really have, I'm not really set up to do that tonight. I'd need to set it up in my Docker container so that it separates it off from the rest of my burp stuff. So I'll do burp another night. So I could do Docker or I could do the Ruby managers. Does anyone else have any other queries, questions, concerns, or thoughts of what we could do tonight before I truck on with either one of those? When you try to scroll up, it returns the last commands I put in. Oh, you're talking about using your scroll wheel? My scroll wheel works. Mind you, I'm using my scroll wheel. It's actually scrolling away the Tmux bar at the bottom, so it's not really scrolling. The way to scroll properly is to do, I don't know if I've got this, I'd have to check my dot files. I don't know if this is standard, but what I do is I go Control X, left square bracket, and you get this little doohickey up here. You get a star down here. I think that's normally there. But the window name comes up in square brackets. Then you can use JK. I don't think you can use JK normally. I think you've got to use up down normally. But then you can scroll up, scroll down, just like that. You can use page up, page down. So is that what you're talking about, scrolling in Tmux, Barney? Because yeah, you can't use up and down, because up and down just go backwards through your commands. You can't really use the scroll wheel because it scrolls the whole terminal, which doesn't make sense when you've got Tmux running, because really Tmux takes control of the terminal and turns the whole thing into a single scrolling pane. So to scroll it, you have to actually interface with Tmux, which is, or for me it's Control X, for you it'd probably be Control B. But you do your prefix key, left square bracket, then up and down you go. And once you're in this mode, you can then move your cursor around, press spacebar to start copying, press enter to stop copying, then you go Control, or you go your prefix, right square bracket to paste. So it's actually the copy paste mode, but you can scroll up and down with it as well. Do you mean the scroll wheel? What do you mean scrolling? Define scrolling. What do you mean the command backwards and forwards? And we're going to do Docker. That's decided. I will put my own time in to do the Ruby stuff another night. Or might save it for Wednesday. We'll see. Also, I'm curious what everyone else thinks. I'm worried that A, I'm running out of material doing this twice a week. B, it's a lot to manage. How would people feel if we went to once a week? Would you be upset because that's less? Or would you be happy because it's like, oh great, I only need to reserve one night a week and I'm not going to feel like I'm missing out if I'm not doing both? Let me know if you would be happy or sad to go once a week. It's not something I'm going to do straight away, but I'm curious what you think. Because if everyone's like, yes, two times a week is too much, that's going to probably seal the deal for me, and we might drop it to once a week. Okay, don't use scroll wheel. I think you can use scroll wheel if you arch wiki tmux scroll wheel, please. Tmux. Jump to mouse scrolling, should have done that. Mouse scrolling. This interferes with selection buffer copy and pasting. To copy paste to from the selection buffer, hold the shift key. If you want to scroll with your mouse wheel, ensure mouse mode is on. So you might be able to just drop this into your Tmux conf. Mouse wheel. You might need to use this instead because you've probably got a newer Tmux. To be honest, I would suggest you get used to not using the mouse wheel. Just for me, like, I can kind of see the merit of going the mouse wheel and kind of being able to just glide up and down. But honestly, once you're used to just typing, you can just go Control X, left square bracket, up, down, really quite easily. And the bonus is it combines with copy paste really quite easily. So give this stuff here a go. See if you can get it to work. But to be honest, I think you're going to be better off in the long run if you learn to scroll with the keyboard. It'll let you copy paste with the keyboard. It'll keep your fingers on the keyboard. The other thing is I think you can scroll one window and still flick between them and it stays in the same spot. You can just go Control C to get out of the scroll mode. It'll go straight back down to the bottom. The other thing is, if you've got multiple panes open, kind of going to want to be able to scroll one of them, and if you use the scroll wheel, I don't know if it's going to do both or one, or if you're going to be focused or what, but if you need to be focusing different panes, you kind of want to have your fingers on the keyboard so you can scroll up between them anyway, and then you go back down and go, yeah, I want this here, copy that. So I'm just not too sure how much the mouse wheel scrolling makes sense. I would recommend you try the keyboard scrolling personally. All right, so Sunday's probably easier. I'm 10 hours ahead, so yeah, okay. What time is it? If you're I'm 10 hours ahead, so it's almost 10 o'clock in the morning where you are on Sunday, I'm guessing. Okay, so you get me with your like breakfast on Sundays. That's not too bad. Happy to watch one or two. Sunday's probably a bit easier than during the week. Yep, so Sunday. Alright, well, let me think about it. If anyone has any strong opinions either one way or the other, ping me and let me know, because I'm curious. No worries, Barney. Hope that answered your question. Let's play with Docker. Let's just head to a temp directory. Docker. What is Docker? Docker is containerization. Actually, you know what? First of all, I'm not the best person to talk about Docker. There are people who have done intro to Docker things on YouTube. You should go watch them. You should listen to the Risky Biz episode with Jess Frizzell. That was quite good and discussed Docker technology and containerization technology quite well. This is all just my opinion and my experience and how I use Docker. I'll preface this with saying I abuse Docker. I use it as a machine creation language. Normally you're supposed to use Docker to host single-purpose applications in their own container. So you'd have a container for your front end. You'd have like an Nginx container or two Nginx containers. Behind that, you'd have a whole raft of application servers running Ruby on Rails or Django or what have you. And you'd load balance from Nginx through to those multiple mid-tier kind of application things, and on the back end you'd have your database containers, and you'd architect you'd design your tech stack around the idea of having these microservices. And a microservice is a container that does one job and interoperates with other containers. That is not how I use Docker. So with the proper use of Docker, you should never launch a shell in a container. You should be starting up a container. That container should start one or two processes purely to do the job that container needs to do. For example, if it's the front end container, it should start Nginx. It shouldn't start Bash. It shouldn't start anything else. It shouldn't start SSHD. You should not have SSHD running on your containers. If you really need to, you can jump on the host and use the Docker CLI tool to basically pop shell in a container. So that's your SSH sorted. You just SSH to the host, then you pop shell in the actual container using the Docker CLI, which we'll get to shortly. But you don't run SSH on containers, and you don't, as a normal course of business, pop shell in a container. If a container is broken, you don't log into it and debug it. You destroy it and you create a new one from the image, which we'll get to images versus containers shortly. So that's kind of the normal idea. You don't use them as you'd use normal machines. The idea is, and I think it was Kane Norton who said this, maybe he didn't come up with it, maybe someone else did, but what he said when he said it really kind of explained Docker to me. It's about treating your machines as cattle, not pets. So in the old way of doing things, we used to have the one or the two or the three or the four servers to do with a particular application, and they had names. Some of them had useful names like application 01 or what have you. Some of them had stupid names like Gandalf or Diablo. But you treat these machines like pets. You'd log in once a week, you'd patch them. You'd log in every couple of months and you'd patch the kernel and you'd reboot it. You'd do backups on it. You would do maintenance on it. You would repair hardware when it got faulty. You would log into the machine each day and actually use it. And you'd have a relationship with it. You'd love that server. That was Gandalf. The idea with Docker is your machines stop being like your pets that you love. They stop being cuddly. They start being, oh, Nginx is playing up, cool, hit the button, it destroys the container, hit another button, it starts a new container. Containers don't have persistent storage typically. If you need to persist data from within your container, you need to do some other tricks. I don't quite understand them because I don't use Docker in the application stack. But yeah, your machines start becoming like a herd of cattle. You know, you take them from A to B and you do stuff with them, and they're not cute, cuddly pets. So that's how you're supposed to use Docker. I don't have experience using Docker in that way. I have experience in what I call Docker for hackers. So with Docker, you get a few things. You get a daemon. You get a kernel. You get images. You get containers. You get remote registries, I think they're called. What else do you get with Docker? I think that's kind of the most important stuff. I'm going to put the kernel first. So when we say that Docker, the kernel is important to Docker, it is your machine's kernel. So when I start a Docker container, for example, this here is one of my, it is a container that I use for Twitch. It's based on the Twitch image, but it's an instance of that image. So we'll get to containers versus images shortly. But this is a container. If you look at the process listing, there's like nothing in it. You know, PID 1 is actually Z shell. There's no systemd. There's no init process. There's no SSH. There's no SSH in here. You've got Z shell. You've got a few more Z shells. You've got Tmux. And you've got Chromium. And you've got PS. That's all that's running in this container. This Chromium is actually running inside the container. So they're the processes running on a container. But the kernel that powers this container is actually Diablo's kernel. It's my host's kernel. All these processes here, they're kind of like in their own little playpen. This is how containers containerization differs from virtualization. So with virtualization, you have what's called a hypervisor. Let's underline that. Docker or Docker is an example of containerization technology, but a lot of what I say will be relating to the idea of containerization, and some of it will be to do with Docker as an implementation of containerization. Then you've got virtualization. So the ideas behind virtualization, you've got hardware, hypervisor, virtual machines, OSs, applications. This is actually basically the virtualization stack, right? You've got hardware, you've got a server that is being used to do virtualization. And then on top of that, you've got what's called a hypervisor. sometimes in here you've got an optional operating system. So data center virtualization does not have this here. The hypervisor is the operating system. For example, VMware vSphere. In that model, you boot off a thumb drive on the server, you go next, finish through the installer, then you reboot the server, and you don't boot into Linux, you don't boot into Windows, you don't boot into anything. You boot into like this ugly screen that says, I got an IP address over DHCP. Please go to HTTP, the IP address, to finish configuring this server. And then you go there over HTTP, you set up some stuff, and then you can start like right-clicking, creating VMs from the remote management application, whether it's a web-based one, hey kitty, or whether it's a thick client. So there's often in the data center no operating system. Like the hypervisor is the operating system. But on the desktop, when you're running stuff like VirtualBox, you do have an operating system here. Could be Mac OS, could be Windows, could be Linux. But then you got this thing called a hypervisor, which runs on that operating system, does the same job as the data center one, just that it lives on top of your day-to-day OS. So this hypervisor basically acts as an abstraction layer between your virtual machines and the hardware. So for example, you've got VirtualBox, VMware Parallel, VMware Workstation, VMware vSphere for the data center, blah, blah, blah. It's kind of like the application or the software that emulates its own hardware and provides the ability for multiple virtual machines to run on the same host. All these virtual machines have their own operating system installed on them. So the good thing about that is you can have VirtualBox running on Linux with Windows inside the VM. That's totally cool. You can't do that in Docker. Docker is Linux only. You can only run it on Linux, or you can run it on Windows or OS X, but when you do that, there's actually a pretty invisible virtual machine layer in there. The way you would use Docker on OS X or Windows is to use the official Docker installer, and I think it installs VirtualBox and actually runs a VM with a very small Linux VM inside VirtualBox, and then so you're back to Linux again. So Docker is Linux on Linux. You can't run Windows in Docker. I think Docker might be running on Windows shortly, but the general idea is that for the most part it's Linux on Linux only. So virtualization, yeah, like you can actually create multiple VMs, you install an OS. When you install an OS onto a virtual machine, like that's actually a machine that you power off and power back on. And whatever changes you make stay on the disk. You've got to patch it, you've got to maintain it, you've got to make sure there's no hackers running around inside that virtual machine. Then you've got the OS, and you've got applications installed within that OS. So this is the virtualization model. And this is kind of it's not really the same, it's not really a stack, it's not really an architecture so much, but these are the ideas for Docker. So you've got your own machine's kernel, and that kernel is shared by all the containers. So all these processes running inside this Docker container actually run on my machine's kernel. The kernel uses technology such as namespaces, C groups, other complicated things, to basically quarantine these processes in their own little bucket. It's like, you're all first-class citizens, you're all processes running on the kernel, but I'm going to hide you all off in this bucket. You can only see each other, because I've got another container over here, it can only see each other. I've got another container over here, it can only see each other. Then I've got the host machine's processes, and you guys running in containers can't mess with me or with anyone else. So it's kind of like carving off sections of your own machine, powered by your own kernel, to run processes within them. And then it comes with some virtual, or not really virtual, but it comes with some networking technology to plumb the machines up, and some other stuff. But it's much lighter weight than virtualization. Virtualization, you've got discrete operating systems installed, so you can have a version of Red Hat, a version of Ubuntu, and a version of Windows, and they're all thick installs. They're actually the full operating system installed on disk. First of all, Docker images and Docker containers don't have a kernel. They don't need a kernel because the host brings the kernel to the party. So they get a little bit lighter because you're not running multiple kernels. But then that kind of brings in the problem with Docker, and that's that if a process inside a container can exploit your kernel, then you're hosed, because they'll do privilege escalation, become root, or just run inside ring 0 inside the kernel, and then all your containers and all of your host stuff is at risk. So it's much easier. Well, it depends on who you ask, I guess. I think it's probably easier to break out of a Docker container and get to the host than it is to break out of a hypervisor, or break out of a VM through the hypervisor and escape into the host. Then again, virtual machines have a lot of emulated hardware, like emulated network cards, emulated graphics cards, emulated sound cards, emulated floppy disk drives, emulated CD-ROM drives. That there's probably a lot of code attack surface there. So it's probably just two different challenges. But I think to say either of them is protection against malicious stuff from breaking out is pretty foolish, because actually I think it was Theo that said it. Theo BSD. Yeah, here we go. This is the best. I love this. Theo responded to someone. Someone said that virtualization seems to have a lot of security benefits. And Theo said, yeah, you're kind of nuts. Virtualization is basically placing on a nearly full kernel full of new bugs on top of a nasty x86 architecture, which barely has correct page protection. Then running your OS on the other side of this brand new pile of shit. You're deluded, if not stupid, if you think that a worldwide collection of software engineers who can't write operating systems or apps without security holes can then turn around and suddenly write virtualization layers without security holes. You've seen something on the shelf, it has all sorts of pretty colors, and I think you've bought it. That's all the x86 virtualization is. So this was pretty sobering to me when I read it, because I used to think, oh, I'll run it in a VM. I'll run this, whatever it is, I'll open this PDF that I don't trust in a VM, because VMs are bulletproof protection. We suck at writing software, we suck at writing OSs, we suck at writing applications. It doesn't make sense that we would be able to magically create a bulletproof hypervisor. So this really kind of opened my eyes to the fallacy that is security through virtualization. Well, maybe not fallacy, but some of the poor thinking that goes into thinking that it's a silver bullet. It's certainly harder. It's not easy to break out of a VM. It's not easy to break out of a container, but theory holds up that it should be possible. So I think that is pretty cool. So yeah, we've talked about the kernel being shared. We've talked about the security issue of that. You got a daemon that runs on your host, and that daemon is communicated to via a socket on the file system, which is owned by the Docker user and the Docker group, I think. Docker control socket. Where is the socket? This it here. So I'm going to go to my host and have a look at this. Yeah, so it's owned by root, and the Docker user has read-write permissions on it. So there's a daemon running that you can talk to via this here socket. And when you talk to it, you can do things like start up new containers, modify the image inventory, check the running processes in as much as kind of check the running containers, do all sorts of things. And the documentation for Docker says that you should add yourself to the Docker group so that when you run the Docker tool to do things like Docker PS, you won't get this error. Because yes, the Docker daemon is running on this host, but as you saw a second ago, this socket is owned by root Docker, and I am not in the Docker group. And so the help manual suggests that you add yourself to the Docker group, so you can go and run docker ps and away you go. You will magically be able to do all the things and all the Docker things. The issue with that is that if you make yourself a member of the Docker group, you essentially become a passwordless sudoer. What I mean by that is normally when you're a sudoer and you do sudo ID, you get asked for your password. And only once you give your password can you become root. If you put yourself in the Docker group, you can become root and you don't need to give your password to do it. Or if you give someone who is not a sudoer, they're not a sysadmin, they're like a developer who's not supposed to have root in production. If you go and put them in the Docker group, it's super easy for them to become root on your box. There is even a Metasploit module for it, but you don't need the root. You don't need the module. You can just you can do it manually. It's pretty simple to become root via the Docker group. Because what you do is you end up creating a Docker image. You build the Docker image. You run the Docker image. And you pass through to that Docker. Does it do it in here? Yeah, this here. What it's doing is it's actually, when it runs the Docker container, it passes through some part of the host file system into the container. Because then when you run a container, you're rooting the container. And if you change the file system inside the container, if it's been mapped from the host, you can change the host file system inside the container. And inside the container, you're root, so it looks like you're root when you change the file system on the host. And if you can hack away at the file system on the host as a root, you become root. You can do things like change the sudo as file, create a suid backdoor shell, change the password file, add a cron entry, blah, 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 all sorts of stuff. So don't put yourself in the Docker group because it makes you a passwordless sudoer. If you are already a passwordless sudoer, don't be. You should always request your own password when you try to escalate. It's the difference between someone popping you as yourself and someone popping you as yourself and then getting to root. So that's the daemon. The daemon runs, and what it does is it communicates with the kernel and performs actions as requested. Things like starting new containers, things like creating new images. Which brings us on to images and containers. Need to crank this up a bit. Oh, nope, need a new battery. So yeah, images and containers. Think of images like templates, and think of containers like VMs. Also, don't think of containerization as being virtualization. But if you need an analogy, I think that's pretty apt, because an image, you build an image based on what's called a Docker file. So a Docker file is like a recipe. So you take a recipe, you run a build process against that recipe. The recipe is just a text file. It gets run top to bottom and a machine gets built. Sorry, an image gets built. So then once you've got, sorry, I've lost my train of thought there. You build images from Docker files, and once you so you have a Docker file, which is like your recipe, you run through it and that's build. And once it's built, it goes into your local inventory as a image, which can then be used to instantiate containers. So a container is an instance of an image. So you start off with an image, you power it up, or you power it up in air quotes, and there's your container, off you go. What you can do is you can take the same image multiple times and start it up as multiple containers. That's totally fine. Once you've already got those containers running, you can change the image. For example, you can go in and rebuild it from the Docker file. The Docker file might have stuff in there like, do an apt-get update, then install these 18 packages. And if you rebuild that image from the Docker file clean, because it has a cache, which I won't get into tonight. There's a lot of cool things to do with Docker. You should read the docs. It's very cool. If you rebuild that image from the Docker file, it will get the latest packages from your upstream distro, and then it will kind of build that image with newer software in it. So that's how you patch. You don't log into a Docker container and do an upgrade. You rebuild the image with the latest software from upstream, and then you start it up as new containers, and then you destroy the old containers. And because there's no important data being persisted within containers, it all goes external to the container to back-end storage volume mappings or something. Doesn't matter. You can just power these things down. They're not pets anymore, they're cattle. And you can power up the rebuilt image, and all of a sudden you've patched all the software. You don't need to log into each machine and actually upgrade it. You just rebuild the image, you start up that image, you do your QA, you do your testing. If it looks good, you just replace the fleet with a copy of the new image everywhere by restarting the containers. So you've got remote registries as well. Things like Docker Hub. Docker Hub has a whole bunch of images in it that you can use really, really easily. You can just do, remember I've got to use sudo docker because I'm not in the Docker group, sudo docker run blah, and if blah doesn't exist on localhost, it'll go and download it from Docker Hub and run it for you, which is kind of cool. Of course, you should not run containers you don't trust. You should not run images you don't trust. You should kind of audit their contents and stuff. But as long as you stick to the trustworthy ones, you should be fine. And it will just kind of run the blah container off of Docker Hub, which is kind of cool. Or you can create a Docker file that starts off with from blah. And if blah doesn't exist on your local host, it will go out and get it from Docker Hub, and then use that as the base from which to build your image from. So you've got these remote registries which provide either full-blown applications, like if we just search for Nginx, like they've got an official Nginx container, or image I should say. Where's the Docker file at? Where's the Docker file at? Is this going to be it? Yeah, there we go. So we start from Debbie and Jesse. We then run this, which will install Nginx and some other stuff. We then run this, which creates some symbolic links. We expose ports. I don't do expose. I'm not too sure about how stuff like expose and networking and port exposing works, because again, I don't use Docker in production. I use it as a hacker on localhost. Then it runs these commands when you start up the container. So you could just go and from Nginx, you could go into a from Nginx in your Docker file, and then what you would do is your Docker file would basically start from this as a foundation, which starts from Debbie and Jesse as a foundation. You can see it's onions and turtles the whole way down. So this is what a Docker file looks like. It's pretty simple. We'll write one in a second. But yeah, that's the remote registry, I think it's called. Yeah, I called it a registry anyway. Is Docker Hub, and from Docker Hub you can get a whole bunch of images that you just run as is, or you use them as a foundation upon which you build the rest of your image. So that's really all there is to Docker. You get an image, and then you talk to the daemon, which uses kernel functionality to provide containerization, and then the daemon will start your image as a container. The image might be straight from a remote repository, or it might be built from a Docker file, which then is based on stuff from a remote registry. And that's like simple, hey? That's really all there is to it. let's just go to a temp directory. So what you can do, for example, is sudo docker run -ti is kind of magical. Let's go read the man page for docker run. -t, what does that mean? Allocate a sudo tty. Let's look for small I. It's probably like interactive or something. Yeah, there we go, interactive, nailed it. Keep studian open even if it's not attached. So TI is kind of magic. You use TI when you're telling Docker to run an image and you want to interactively drop into something like a shell. If you didn't give TI, you wouldn't be able to interact with the shell that runs. The shell would start up, then quit straight away. So we do sudo docker run -ti. Debian is the name of the image, which comes from the remote registry, Debian. There's an official repository for Debian. It's a Linux distro that's composed entirely of FOSS software. You've got all these tags, so what you can do is you can either do Debian or Debian Jesse or Debian testing or Debian stretch or Debian Wheezy backports or Debian stable backports or SID or what have you. We're just going to do Debian for simplicity. So Debian is a thing out in Docker Hub. And what do we want that container to do when it starts up? Run bash. There it is. That's so much quicker than it takes to start up a VM, hey? And that's basically going to smell and feel and touch and taste like a VM. We can do ps-a, or ps-ev I should say. There's two processes running. One of them is the bash that we told it to start up. The other one is the ps that we're running. And we are root inside the container. And we have an IP address on a private little it's kind of like VirtualBox's NAT networking by default. I think I went and hacked at some of the config on mine so that I could do some cool stuff, but I can't remember what I did. So I'm not going to get into the hacking on the config of Docker, but I think I've hacked mine, so yours might look a bit different to this. But you've got an IP address you can ping out, that's fine. You can apt-get update. Well, let's run Vim. Vim's not installed. Let's go to the local host and run Vim. Vim is installed. So this Debian image has like no software in it compared to my machine, which I've gone and I've installed software onto, obviously. So with an image, you've got, again, you've got no kernel. The kernel is provided by the host machine. But you do have what in Linux is called a userland. So Linux is split into two things. There's the kernel, which people like Linus Torvalds hack on. Then you've got the userland, which is what people like Nginx, Apache, GNU, the people who make Vim, Bash, Emacs, Python, what have you. That's all kind of software that when you kind of add it all together, it's called user space or userland. I can never remember which one of those, or maybe it's both. So a Docker image is basically a userland that's been smashed together, but it's a pretty damn minimal userland. For example, you don't even have vi. You got this in bin, that looks pretty normal. That user bin, yeah, you got quite a bit of stuff, but nowhere near as much. If we do user bin, count the lines, you've got 239 files inside this Docker container. On my local host, I've got 2,500 files in user bin. So there's a lot more software on localhost. But there's nothing stopping you from doing apt-get update and apt-get install Vim. And you can install Vim on your container. And off it goes. Now I'm not going to, that's actually pretty quick. I will sit here. we now have Vim installed on our container. That's kind of cool. We can install software in containers, and all the software we install on here won't pollute our host system. So let's say we leave for the day, we exit the container, we shut down our machine, we come back the next day, and we want to run Debian again. You know, we kind of run the same command that we ran yesterday, and we know that we've got Vim installed already. Oh, it's not there. Because when you exit out of a container, it doesn't destroy the container, it leaves it in a dead state. I'm not going to show my process listing or my dead Docker machines because I've got a lot of stuff in there. But you can dig it back up if you go and look at your Docker processes and you look at the ones that are all in the stopped state. You can actually go and revive. This here is a machine ID or a container ID, and you can see it's different each time you start up. Even the same image, the Debian image, you start it up twice and you get different IDs. So you can actually go and revive this this container the next day. That's totally cool. Like, the files will still be on disk, Vim will still be installed, but you shouldn't do that because remember, we're trying to get away from our containers and our VMs and our machines being like pets, you know, cute cuddly pets. I installed Vim on it and I kind of gave it a little pat and said good boy, and then I put it to bed and then I got it up the next day and I used Vim again. You want to get out of the habit of doing that if you want to make the most use of stuff like Docker and be totally hip Silicon Valley-ish. So how do we if we're going to use Vim in a container every day, and we want to use the container interactively by just running bash in it, which is how I use Docker. I just want to kind of drop to, so if we go back here, you can see I've got my pwn tools, I've got a whole bunch of tools in /opt, I've got my nice prompt, I've got a user called Justin, I've got the time being shown, I've got these machine IDs showing up, I've got D for Docker in my prompt. Like, it looks like home, but when I power this Twitch themed Docker that has Chromium installed and some other stuff down, I don't come back the next day and use the same thing again. It's kind of like leaving you walking out the front door, blowing your house up and going, oh, I'll rebuild you when I get back. How do we, if we want to kind of have our own custom little home-like environment that feels familiar and has the tools we need in it, but we don't want to reinstall them each day, and we don't want to kind of keep reusing an old container ID that over time will get crusty and old and have a heap of software we don't need and don't want, and all this data. Like, I went through VM hell 6 months ago now, 12 months ago now. Yeah, time flies. Where I had a whole bunch of VMs on a host that was powered off in the corner for years. And I've just gone, I need that data. I haven't needed it lately, but I know there's important stuff on there. And I had to power it up and power on each VM, and I couldn't remember the passwords, so I had to get a boot ISO and boot each VM off the ISO and change the password and get the data off and blah, blah, blah. You don't ever want your data to be trapped inside a container that you reboot each day. Like, it's just not fun that way. What you can do is for example, this Twitch container here, if we go cd, like for example, work/micro-corruption. Here's where we were doing all that micro-corruption work. This here is a directory that's mapped from my host into the guest. And you can do that with the -v command. I won't get into data volume mappings tonight, but there is a way to have the equivalent of like a shared folder in VirtualBox over in Docker, and that's where I kind of keep all the data. There's nothing, pwn tools I kind of copied from /opt, I think. When I power this down, that'll go away. I don't really care about it. All the important stuff is stored in these, which get mapped from the host to my guest. Sorry, to the container. So that's data. How do we get Vim installed on a container and not have to start it up each day? We create a Docker file, which basically instructs Docker as to how to build our own custom image based from Debian with Vim installed. So we create a text file called Dockerfile. we do from Debian run apt-get update and apt-get install -y, I think it is. Apt-get -y. Still okay, cool. I think it's apt-get -y install vim. And the reason why we do -y is if you recall, let's just background this. Up here when we went to install vim, here's what we did. We did apt-get update and apt-get install vim. When we did this, we had a question be asked: do you want to continue? When you build based on a Docker file, you're not allowed to ask for user input. If anything during a build of an image asks for user input like this, the build will fail, because building is supposed to be something that can be done on headless servers and build boxes and build farms and blah blah blah. Asking questions is bad, and so the build process will fail if you ask a question. The way to get around that is to bake this -y, which is just answer yes to all of the apt-get questions. So from Debian, run apt-get update and apt-get -y install vim. Save that. Is it actually deprecated? Because I know I need to get in the habit of apt. I have used it, but I keep forgetting. Is apt-get actually deprecated? This is a lot of chat. That's a lot of chat. I might read this later. If there's anything important up here, please ping me with my name in it. I don't have time to read all this one. I'm so sorry. I should have been keeping up, but I'm not going to go back through that now. I want to finish this off and head to bed shortly. It's just apt now. I don't know if it's something about deprecation, but I keep getting told by the neckbeard. Yeah, the neckbeards will yell at you and say it's the way to go. Hey, I mean, to my credit, I think I did like IP space A. Yeah, at least I didn't use ifconfig. I did one newfangled thing, because I yell at people when they use ifconfig, so I should start using apt as well. But yeah, thanks for that, Blue Pill. Sounds like you've got the questions under control. So we got a Docker file. We've got not a lot else in our little lonely temp directory. So the Docker file is going to, from Debian, run apt-get update and do this headless, questionless install of vim. I would change this, but I'm scared of it breaking. I don't want to debug apt, whether it's in Debian or not, based on, because this is still Debian stable Jesse as well, not stretch. Anyway, so now how do we build this Docker file? I think we just do sudo docker build. I've got this written down, but oops, my bad. I've got this written down, but it's in a text file I can't share because reasons. It's got other notes in it. How do I build? Cool, thought so. So we do docker build -t to give it, I think it's a tag or a name, and docker build -t, yeah, it's a tag, repository name, and optionally with tags to be applied to blah blah blah. So the normal way to name your images is with like a company name or a personal name first. I think that's how you're supposed to do it anyway. /vim. So what you do is you do the name of the entity that's creating it / the name of the image. At least that's the convention I use when I do mine. So do sudo docker build -t, give it a tag, the path to the directory containing the Docker file, which in this case is dot. Now, there's something else called a build context, which I won't get too deep into, but suffice to say that when we do this Docker build, it's not just using the contents of this Docker file to build the image. It's also sending or copying all the bytes up into RAMs to send them up to the Docker daemon running on localhost, the contents of the whole directory. In this case, there's like nothing in there. We'll just comment this out and go doot. Then there's an extra file, doot. It's a 0-byte file. Let's put doot in it. Give it some meat. So doot is now a 5-byte file. When we do this Docker build and send up dot as the build context to the Docker daemon to do the build on, it'll send the contents of this whole directory up to the daemon, including a whopping 5 bytes worth of doot file, which isn't a lot. But if you've got like 8 gigs of random bullshit in your directory that has your Docker file and you do a Docker build, it's going to sit there and go sending context, sending context, sending context. And it's going to make the build really slow and annoying. I don't know if it has any other side effects. I don't think it does. The reason it sends the contents of the entire directory within which the Docker file is based is because inside the Docker file you can do, is it add or copy? There's 2 commands, add and copy. They do the same thing, almost, but one of them is recommended versus the other. By the way, read this page. Read the Docker file reference. It's sensational. It's all you need to know plus a lot more. Add has 2 forms. Okay, add does remote URLs. I think it's the one that's not recommended. Let's do copy. I think copy is one you should use. You can do copy doot to /root/doot. And what it'll do is it'll actually copy this doot file from the build context. Remember, it's the entire contents of the directory that is sent to the daemon that the daemon can then use to go, I'm going to copy the doot file to over here because I was told to do it. You can only copy stuff in the current directory into the container. You cannot do copy /doot to /root/doot. Won't work because it's not inside the build context. You got to do copy doot to root doot. They make me laugh. So that's what the build context is called. When you kind of get down the track of building your super wicked Kali replacement, which I have my own Kali replacement, it's actually what this here is based on, and you can see that this is all it has. It's got the tools I need and nothing I don't, except it doesn't have burp. But it's got Metasploit, it's got John the Ripper, it's got GoBuster, it's got Peta, it's got Pwn Tools, it's got Radar2. So these are for binary. Whoops, these are for binary. These are for punching out modules and using modules. Password cracking. The cool thing is I can actually send this image up to the cloud and run a password cracker out there if I needed to. SQL map, WP scan, some basic tools. As I need to use more, I add them. Until I need them, I don't. What am I missing? Yeah, I heard the same thing, Will Jr., that, yeah, apt is missing a couple of things. But I'm sure, I do know that it's the way they're going forward, so I'm sure it will catch up. I'll answer that in a sec. Yeah. So when I rebuild it, so every couple of weeks I do a build of this image here, upon which my Twitch flavored one is based. Really, I've only got one base image. It's called Jax. It's a dumb name, but it has a legacy of being based on something which was based. It's an evolution of machines, and it's now called Jax, J-A-X. Jax has this stuff in the home directory, except for Twitch and work. Work is, I've got a whole bunch of stuff on localhost in the work directory, and it's where I just keep everything I'm working on. And I slowly map these into the Docker machines, Docker containers, sorry, one thing at a time. All this stuff is in Jax. And then whenever I want to use Jax to do some stuff for Twitch, I just map through the Twitch specific stuff like Twitch and work/microcorruption and work/MSF pattern create pi. When I want to do other stuff, I run Jax with the other stuff directories passed through. But every couple of weeks what I'll do is I will rebuild Jax from scratch. Jax is a huge Docker file which has a whole bunch of software I install from apt, a huge pile of software I get from GitHub, a huge pile of other stuff that I have in a Docker file, how to actually install it, and then I do a Docker build, and it will, from scratch, rebuild it. And it will rebuild it with the newest, latest software. It will rebuild it with the newest, latest stuff from Git. It will rebuild it with any changes I've made to the Docker file in the last couple of weeks, all from scratch. So every couple of weeks I rebuild Jax, and it takes about an hour because Radar 2 has to be compiled, some other stuff has to be compiled, John has to be compiled. You've got to reinstall Ruby and a whole bunch of other stuff, but it's worth it because for the cost of writing one Docker file and spending 1 hour every couple of weeks, you get like a completely brand spanking fresh, clean image with the latest software in it that you can spin up 5 copies of if you need to. Containerization is so lightweight that there's nothing stopping you from starting up 5 containers at a time if you really need to. It scales really quite nicely. So I hope that answers the question, Pritch. Yeah, it is a bit slow. But then again, kick it off, go to bed, wake up, brand spanking new image. And really, yeah, it's slow. But you do it once every couple of weeks and it takes 1 hour. Otherwise, you're doing what? 1 hour for each machine every couple of weeks to actually install patches. Like, it does make sense when you've got a generic image that you're spinning up in multiple places at a time. You patch once and it's kind of then ready for running everywhere. Because I don't have a good graphics card, Jardet, and old habits die hard. I haven't learnt the hashcat syntax and the hashcat interface yet. Plus, I never do password. I almost never do password cracking. If I do password cracking, it is for a CTF or a boot to root. I've been meaning to learn hashcat, but I'm actually running on a laptop. I don't have a desktop. I've got a really old desktop in the room next door, which I run some other stuff on, but it doesn't have a graphics card either. My laptop has onboard graphics and an NVIDIA Optimus card, which I don't like using because it heats up the laptop. I don't have a graphics card. I don't do password cracking. Can you emulate network connectivity between the Dockers? Yep. I.e. build a boot to root network? I don't know. I don't know if you can specify that you should have. If you're thinking of like the PWK labs where like it gets deeper and deeper and there's like a few layers deep, maybe you could do it with Docker, but I'm not too sure. Have a look. Let me know how flexible you find the networking. I've found the networking just flexible enough for what I need. I don't do elaborate stuff. I do some port forwards and I do some tricky stuff, but it's not too crazy. So let me know how you go, Blue Pill. Hashcat's good for just CPU too. Okay, maybe I should learn Hashcat for my CPU cracking, so that in the event that I do find myself with a good graphics card, I'm home and host already. It's probably a good idea. Alrighty, let's finish off this Docker stuff. Where were we? Copy doot to root doot. That makes me laugh. See, we've got a Docker file. We do this build based on dot. In dot, there is this small file doot, and it doesn't really matter, it's small. It'll upload it from disk into the daemon into RAM, and 5 bytes, who cares? If it was like 5 gigabytes, it would make your build super slow. The point is, don't have a lot of files that you don't need in the build context because it has to be uploaded or basically copied into RAM for the build to happen. So it's sudo docker build, give it a tag of this based on dot, enter. So from Debian happened really quickly. It's now running this, and it's running in that container there. I'll wait for this to finish and we'll explain some stuff. So I don't fully understand exactly what these are referring to, but you got like IDs and hashes and stuff. What's, so I've got 6 CCD, were either of these? Yeah. I did not removed intermediate containers. Anyway, you've got this idea of layers. So a Docker container, sorry, a Docker image is made up of layers. Although this here has challenged something. Oh no. Remove the container, not the image. Okay, cool, that doesn't challenge what I thought. My understanding is that a Docker image is based on layers. And each time you do something, like from Debian, says, okay, let's just get the pile of layers that is the Debian image. And then do this. What it will do is it will start the container that has been, it'll start the image that has been produced so far as a container. Do this, shut the container down, and capture the state of the disk. More specifically, I think it captures the difference, like the delta between the delta between before doing this and after doing this. It'll capture the delta. All the files that got written to disk as part of this action, it captures as a new layer. And it's kind of like in Photoshop with all the layers, you can turn them on and turn them off, and you build them up bit by bit, and they're kind of like onion layers, and you can see through them. Docker images are the exact same. It's based on a pile of delta images. Or delta layers. And so what it did during this build is you can actually watch it with all these hashes popping out. It's actually building up the layers of the hashes and the images, and each time it builds an image, it hashes it, and then it stores the hash and reports on them. So what it means is that you only need to download the from Debian once, and then each time you build from it, it will just pick up from the cached copy and then apply each layer. And if we were to have this Docker file here, and then we'd have another one with another line after this one, it just forms this blob of layers on disk. And it's kind of like a couple of decks of cards sitting around sort of thing. And each time you then go to say, I want to run the Justin Stevens /vim image, Docker's like, okay, cool, I'll get this, sandwich them together, and then put it in the toaster and run it. So it's super flexible. If you've got images that you write that kind of start off the same, but then they diverge, then Docker is really efficient in making sure that it only keeps on disk, or it only needs to keep on disk the layers of images that are needed, and it's kind of like, it dedupes layers. There you go, we'll put it that way. Which is really nice, because if you've got multiple containers running at once that are all based on from Debian, then you're probably going to have all the files to do with that layer or that image in your hard drive cache. And if you've then got a whole bunch of stuff that runs the exact same thing, you'll have a whole bunch of stuff in your hard drive cache, and it's good for your disks, and it's just great. It's got a lot of advantages. It makes your compute resources so much more liquid, maximizes the use of disk caches. It's really good on storage space. There's so many reasons to love Docker. Anyway, now we can do sudo docker run -ti for interactive, Justin Stevens /vim bash. There it is, vim. It's installed. So by building this Docker file here, and building it as a image called Justin Stevens /vim, and then running the Justin Stevens /vim image as a container, and this container popped up, it has Vim installed. That is the basics to writing Docker files. One last thing, remember how I was saying that every time you create a new layer, in a Docker image process, it has to capture all the deltas that got introduced in that stage. This here created a whole bunch of crap on disk. First of all, actually, you know what? Let's. What you can do is you can do \enter, and it will kind of continue the same command. We can indent it, \enter, \enter, indent. There we go. So this kind of, you can see the flow here. Here's the list of packages, and here's the commands. And this here had a couple of effects. First of all, it installed Vim, obviously. It installed Vim into /user local bin. It installed all the Docker. It installed all the libraries that Vim needs. That's great. But it also would have left the .deb file of all the packages that were needed for Vim in the dpackage cache. This update here would have populated the catalog on disk of all the packages that can be installed. That's a lot of extra files to be captured in that layer that we were talking about. I'm just going to go back to my Docker file that has some super secret squirrel stuff in it and grab some stuff. Yeah, let's grab this. Okay. So what we can do is do the apt-get update, and then do the apt-get install vim, and then do an apt-get clean, and then remove everything in varlib app lists star, temp star, and var temp star. This will just make sure it basically obliterates all the unnecessary cruft that got left around from that install process. So we'll do a right quit, and we'll just do a rebuild. And now this rebuild, it got to reuse the Debian layer, but we changed this line by adding some stuff to it, because we want to make sure that we do the clean, all the cleanup stuff as part of this same layer, so that all of that bullcrap doesn't get caught in the diff, in the delta. The super neat thing about doing builds is if we'd left this line the same and put some stuff after it, the build process basically picks up from the last most thing in the Docker file that didn't change. Which means if you want to do a complete rebuild and get all the new software, you need to do, like, I think it's like --no-cache or something like that. And Docker build cache, yeah, --no-cache. You need to do --no-cache to make sure it does it completely clean and gets rid of all the old software and installs all the new software from scratch from the top of the file. Otherwise, Docker, in its super duper efficiency, will pick up the build process from the most recent thing that didn't change in the Docker file. So now we can do the Docker run again, and the container still works, and Vim is still installed. The good thing is, cat Docker file, by adding this on, it made that image a little bit smaller, which is good for performance, good for hard disk space, and saves the digital whales. So that's my very brief introduction to Docker. So the idea of an image is kind of like a template. The idea of a container is it's kind of like a VM, but containerization is not virtualization. It's super lightweight. It's Linux on Linux. You write these Docker files, and you build them to get images, and then you create containers from those images. You can create multiple containers from one image. You can refresh your image by doing a rebuild every couple of weeks to get the latest and greatest software as per your apt-get installs. Your Docker file can have, run, git, clone, blah, 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 make, install, blah, blah, blah. That's all fine. You don't need to, it's really nice to have a very clean Docker image. But once you've actually started up a Docker container like this one here, I get super lazy and I just chuck files everywhere. because you don't need to worry about junking up your host or breaking your host or installing software that you can install all sorts of software from apt-get inside a Docker container and not have to go, oh, I should uninstall that rubbish before I forget about it. It's like, nah, just kill the container, let it all disappear into the ether. You can play super loose and fast with your containers because you're not junking up your host. So now what people need to do is go away and write a Docker file that has all the software you need in it and nothing you don't. And the really good thing is then, once you've got this Docker file up and running, it's so much smaller than Kali and it's so much easier to keep up to date than Kali. You just do a rebuild once every couple of weeks and you're done. You could print this out and type it in each time if you need to. It basically means that instead of a multi-gigabyte ISO file, you've got one text file. And from that text file, you can rebuild your Kali-like container anywhere, anytime, as long as you've got an internet connection. So that's why I like Docker. That's how I use Docker. I've got some shell scripts that I use to do that build. So it's basically a shell script that does this. I've got another shell script that does this. But the shell script, well, it's actually a Python script, takes an argument that says, what sort of image are you starting up today? And I go, well, it's a Twitch one. And it's like, oh, okay, cool. I got you, fam. I'll pass through this directory. I'll pass through that directory. I'll turn this option on, blah, blah, blah. And it makes it ready for Twitch. So I've got a shell script for build. I've got a shell script for run. I've got a really, really, really long Docker file with a whole bunch of software that I love using in it. And that there, like a couple of text files, is basically enough for me to recreate my own personal Kali with only 1 hour to spend building it. So hopefully that makes sense. Hopefully that's been useful to some people. But that is how I use Docker, and I'm a hacker, so that's Docker for hackers. Any questions, queries, concerns? Is this hard to use? You talking about Docker, Josh? Is Josh still around? Aha. Thank you. That makes a lot of sense, old mate. Keep using apt-get for scripts because its API is guaranteed. That makes a lot of sense. Appreciate your input a lot. Okay, old mate Foo, how does overlay 2 work? I haven't looked into much on the mechanics, the underlying mechanics, so I'm super curious as to how that works. Why do I use Debian? Because I used to use Ubuntu and was super sick and tired of all the extra crap it has and all the extra crap it installs. And when it comes to Debian, are you asking why I use Debian in general, or why I use it on my host, or why I use it in a container? Because the answer is similar but different for both. Why do I use it on a host? I used to use Ubuntu on my host, and I got sick of Ubuntu, and I went to Debian, and I fell in love. I didn't like Ubuntu's Dash stuff, where they introduced Amazon ads into your Dash searches. Like, that's just messed up. Didn't like Unity. And I always used to install i3 anyway, so it's like, well, I'm not actually using any of the Ubuntu isms. I'm just going to go straight to Debian. I feel it's more lightweight. I feel I love that it's community driven and not corporation driven. I love the Debian community, so I enjoy using Debian. Jardiff, that's not why I use Debian. I find the stuff is easy to use and install on it, but generally I don't use packages for my hacker tools. I use packages for stuff like Python, Vim, curl, wget, Chromium, Open Broadcaster, URSI, VirtualBox, the core stuff, but all the stuff like WP Scan, SQL Map, Burp, obviously Burp there's no package for, Well, there might be a Kali package, but I don't use it. Metasploit, Pwn tools, all that sort of stuff. I use it straight from the project on GitHub. So I just git clone and I run it out of my home directory, or I put it on the Docker image and run it from there. But I don't install hacker tool packages. I run straight from source for a couple of reasons. First of all, I like being on bleeding edge for features. Second of all, I don't trust the maintainers and the packages. I'm sure they're fantastic people, but I would rather, if something's breaking, for it to be the project stuffed up so I can help them with a bug report. I stuffed up so I can learn what I did wrong, not because the packaging stuffed up. Third reason is I like to be able to run straight from source, so that if I find a bug that I know I can fix, I just cd into /opt, hack away at the code, branch, add, commit, push, pull request, and there you go. I can actually contribute to the projects that give me the tools that I use. So that's why I don't use packages. I run straight from the source. Heaps useful. Okay, cool. I'm glad you enjoyed it. Fast char. Yep, it'll be available as a Twitch VOD. And when I stop being lazy, I'll go through all my old VODs and go export to YouTube, export to YouTube, export to YouTube, which I should make sure I do before Wednesday, because I'm probably about to have some stuff expire. In fact, I might be having some stuff expire tonight. I should upload stuff to YouTube from the Twitch. But yes, it will be available as a VOD. Don't take anything I said tonight for gospel. It is just my understanding of it all. There are much smarter people than I, and I am probably wrong on a lot of counts. It's just how I see it and how I use it. So don't use me in your pub arguments as to the mechanics or the best practices of Docker, because I don't understand the mechanics and I don't use it according to best practices. What in general? Yeah, there you go. Love the community. Don't like the Ubuntu Corporation. Don't like the Ubuntu OS. But I do like Debian's way of packaging stuff. I just love that it gives me the warm and fuzzies that it's a community distro as well. Yeah, there you go, Parks. Glad you got something out of that. It's it's definitely not the enterprise use. It's definitely just using it as an alternative to VMs for moving quickly and breaking stuff on local hosts. So glad you enjoyed it. Chuck-S overlay 2. Internally it's close to how Ubuntu works, but Fedora doesn't have that FS, so it falls back to the really terrible default. More reading. I will open that in a tab. I will read that after the stream. Thanks for that, old mate. Appreciate it. If there's no more questions, I'm going to have a bit of an early one tonight. Going to head to bed, read a book. I'm not going to read a book. I'm going to watch Netflix. So this is last call for questions, last call for comments before we call it a night. I know there's lag, but speak now or forever hold your peace. We'll hold your peace until Wednesday. Cool, sounds good. Yeah, thanks, Park, will do. No worries, my lord. It was my pleasure to be able to share what I know. Do I work out? I do a bunch of indoor rock climbing, generally on Tuesday nights. Will Wednesday night still be on? Probably. How do magnets work? Ask your parents that one. Can you redo it for me? Yep. If you just go to the videos tab, I'll see you over in the videos tab, and I'll do it again for you there, Barney. So yep. At this stage, Windows. I need sleep. Wednesday will still be on. I don't know what I'm going to do yet, but I'll find something to do. I might do my Ruby stuff then if I haven't done it by then. Oh hey Alana, did you just get here? Have you tuned in as I'm just about to head off? Have you? I can't see you here. Well, Alana, if you head over to the videos tab, you can watch me waffle on about Docker over there. So thanks everyone for tuning in. Oh, Blue Pill's got a binary I can do. Let's talk offline. You should send that through, and I will do that on Wednesday. Thank you very much for tuning in, everyone. It's been a pleasure streaming. It's been a pleasure having you here. Do I use Windows for the streaming? No. This here is i3 running on Debian. This here is Tmux running inside URXVT. This is Chromium. The software I use for the actual streaming is Open Broadcaster. Open Broadcaster software? Open Broadcaster. It's OBS. Open Broadcaster software. This is the broadcasting software, so there's no Windows in this stack. Sometimes I use Windows when I'm streaming, when I need to use IDA. Apart from that, no, I don't use Windows. Oh, you've been here, you've just been quiet. Cool. Thank you very much, everyone. I'm going to call it a night. Thanks for dropping by.